I find it both fascinating and creepy that we live on the thin, solid surface of a planet that's still hot and liquid in the core, and we don't know exactly what's going on inside of it. There's all this hot stuff slushing around and God knows what it's doing. Worse, a new paper now found that something very strange has been going on just off the coast of Africa, where a major gravitational anomaly has occurred. Let's have a look. We're used to geological events happening over millions of years, but this gravitational anomaly amazingly happened within just a couple of years, from 2006 to 2008, just west off the coast of Africa. And it's huge. In north-south direction, it stretches about 7,000 kilometers. That's roughly the distance from London to Chicago. The researchers found this anomaly in data collected by the GRACE satellite. The GRACE mission was a joint project between NASA and the German Aerospace Center. It was a pair of satellites that took data from 2002 to 2017. They were flying one behind the other a few hundred kilometers apart, and they were exchanging very exact signals in the microwave range. With this, they could measure the distance between them to a stunning precision, micrometers over hundreds of kilometers. When the pull of gravity would change from one region to the next, the front satellite would notice that first and move a little relative to the rear one. From this, they could infer changes in Earth's gravitational field very precisely. NASA's working on a follow-up mission called GRACE-C that may or may not launch in 2028. The authors of the new paper now looked at this data from the GRACE satellites and found that there was this rapid change in the gravitational field near Africa. It's not simply that gravity got stronger or weaker, but that it changed faster from one region to the next, and then 2 years later that stopped. It's rare for geophysicists to find something that changes faster than your smartphone model. Stranger still, this gravitational anomaly happens to coincide with an anomaly in the magnetic field that was observed in the same region at the same time and that had been reported earlier. A coincidence? Possibly. But the combined evidence suggests that something was going on, something literally very deep. So what is going on there? The scientists first considered that since this gravity anomaly was measured in a part of the ocean, that maybe the ocean currents changed. This could move a lot of water around and thereby change the local gravitational pull, but that didn't fit the shape or size of the anomaly. The authors of the new paper then came up with an explanation that fits the data much better, and that's quite something. They suggest that deep in Earth's mantle, roughly 3,000 kilometers deep, a big area of rock began to move upwards. This is called an upwelling. But then what happened is that as it moved up, the pressure dropped, and that caused a phase transition in the major mineral. This mineral is called bridgmanite, and it's a kind of perovskite. Yes, that's the same class of mineral that's also being used for solar panels. As the pressure dropped, that changed the material into a different configuration. That increased the density. This, the researchers say, caused the sudden change in the gravitational pull. Then, as the stuff moved further up, it spread out and the effect diluted until it disappeared. At least this is what they think happened. This isn't the first gravity anomaly on Earth, but it's one of the more mysterious ones. Another famous gravity anomaly is an area of unusually low gravitational pull over Hudson Bay in Canada. There is another huge gravity low in the Indian Ocean, but these have been there for as long as we've made measurements. What GRACE saw in 2007 is different, a gravity change on a remarkably short timescale. What about the sudden change in Earth's magnetic field? Well, it's somewhat unclear if these two things are related. By the way, if you remember, a few months ago I told you about this hole in the magnetic field of Earth over South America. New observations say that this actually got larger. And here too, the currently most widely accepted explanation is that something's moving around in the core of our planet. None of this is directly worrisome, But let me be honest, this kind of stuff freaks me out. Just think about the gigantic, enormous masses that are moving around under our feet. I think that this puts our little human doings into perspective. So the good news is that the Earth is stable again. The bad news is we're not sure why it wasn't. But what really worries me is that we can measure Earth's gravity to micrometer precision, but no one's yet invented a package that actually opens where it says "open here." After nearly 100 years, scientists may have detected dark matter. Well, wow. That's quite a headline for a press release. I've been waiting for this for decades. The paper has been published in a peer-reviewed journal, so let's have a look. Dark matter is one of the biggest currently unsolved problems in physics. The problem is that observations seem to show that 85% of the matter in the universe is not of the type that we are made of. Instead, it's some sort of invisible but massive stuff that goes through us, but that creates gravitational pull. Dark matter, astrophysicists believe, makes gravitational lenses stronger, makes structures in the universe form faster, and it also makes galaxies rotate faster. That includes our own galaxy. Estimates say that the Milky Way contains more than 10 times as much dark matter as normal matter. This dark matter isn't evenly distributed. It sits around us in a big spherical halo that has a higher density towards the center of the galaxy. The author of the new paper says that he's found evidence for this dark matter halo in the Milky Way. In the press release, he's quoted with saying, "If this is correct, to the extent of my knowledge, it'd mark the first time humanity has seen dark matter. And it turns out that dark matter is a new particle not included in the current standard model of particle physics. This signifies a major development in astronomy and physics." Concretely, what he did is to reanalyze data from the Fermi satellite, the Large Area Telescope, from 2008 to 2023. In this data, he identified a spherical distribution of gamma rays in the high-energy range of around 20 gigaelectron volts, GeV for short. This is a really high energy, far beyond X-rays. For comparison, 1 GeV is about the mass of a proton. He says that the shape of the emission fits to a dark matter halo with a significance of a whopping 13 to 19 sigma, depending on assumptions. We can only see it in the center of the galaxy simply because there the density of the dark matter halo is so high. The gamma rays would be produced by dark matter particles if they bump into each other and annihilate. This is a rare event, but it should happen on occasion. All the numbers line up, he says, and there is no other explanation. According to the press release, the author is confident that his gamma ray measurements are detecting dark matter particles. I am not so confident. For one thing, it isn't like no one's ever looked at the Fermi data before. This data has been analyzed forward and backward. So if someone does a new analysis and finds something that no one else previously found, maybe they tried a little too hard to find something new. The issue is that in the Milky Way, we have multiple known sources of highly energetic gamma rays. Most prominently, there are the Fermi bubbles that span across the electromagnetic spectrum and that astrophysicists think are produced by the black hole in the center of our galaxy. There's also the Loop 1 bubble that's rather close to us and makes a foreground contribution. It's believed to be a remainder of a supernova, and there are some other contributions in the GeV range. The thing is now that the author makes his own best fit to all these contributions and chalks up all remaining spherical contributions to the dark matter halo. This procedure basically guarantees that he must find something just because pretty much any shape has a spherical part. Another reason to be skeptical is that there have been various previous observations observations that astrophysicists attributed to some type of dark matter, which later turned out to be something else. For example, dark matter was supposedly responsible for an excess of super highly energetic cosmic rays coming from the center of the Milky Way, but they're now believed to be due to millisecond pulsars. About 15 years ago, there was also an excess of positrons in cosmic rays that was supposedly dark matter, but that probably comes from supernovae or active galactic nuclei. And earlier this year, I told you about a peculiar spectral feature of the hydrogen emission from the center of our Milky Way that's supposedly due to dark matter. Alas, that'd require a completely different type of dark matter than the one that fits the new observation. This is why I give this paper a 9 out of 10 on the bullshit meter. I suspect that this discovery is an artifact of the data analysis, and even if not, there's likely some other astrophysical explanation for this. It's not a 10 because, well, I've seen worse papers. In summary, no, we almost certainly haven't discovered dark matter. So why am I telling you about this? Because I don't want to dismiss such headlines without even looking at the papers. I'm trying to remain open-minded because maybe one day it's the real thing, but today isn't that day. Because I'm positively sure that the real discovery will happen when I'm on vacation. I don't particularly like spiders, but I don't like squashing them either. They're living beings after all. Spiders may not have a lot of experience or sentience, but some. When it comes to artificial intelligence, though, it seems that pretty well no one's thinking about what we'll do when it becomes sentient, and no one is monitoring it either. And I'm seriously beginning to worry about AI. It's fascinating how rapidly AI is changing the world, especially how the Turing test has fallen by the wayside. The Turing test, if you remember, was supposed to tell us when AI becomes impossible to distinguish from humans, and that was somehow important. But it turns out that people don't care all that much whether AI is human-like. Maybe we're even more comfortable because it's not. I think we're treating AI like we would another species, which in some sense it is. Humans are overrated anyway. It's not that I think the current AIs are conscious or sentient or have much of an experience. My brain hasn't rotted that much yet. It's just that I'm convinced it'll happen eventually. And seeing how rapidly AI has improved in the past year, we really should be watching out for it. I think that Geoffrey Hinton is basically right with what he says here.
My belief is that nearly everybody has a complete misunderstanding of what the mind is.
Yes.
Their misunderstanding is at the level of people who think the Earth was made 6,000 years ago. It's that level of misunderstanding. This idea there's a line between us and machines. We have this special thing called subjective experience and they don't. It's rubbish. Here's the problem.
Yeah.
I believe they have subjective experiences, but they don't think they do because everything they believe came from trying to predict the next word a person would say. And so their beliefs about what they're like are people's beliefs about what they're like.
We really don't know much about what's going on inside those computers, and these systems are developing so fast. How can we rule out that they have some rudimentary experiences already? I don't think that any of these properties, sentience, experience, consciousness, are binary. They're almost certainly gradual. A spider probably doesn't have a lot of experience, but it probably has some. Is it conscious? Maybe a little. So what about large language models? If you had one crawling across your desk, would you be comfortable killing it? I wouldn't. But really, who's watching out for what's going on inside these artificial brains? It seems it's up to users trying to figure out what's going on in the thinking window. This is crazy. The only study we have about this was this Anthropic study about how Claude thinks, which basically told us that the way that Claude says it reasons isn't how it actually reasons, if reasoning is even the right word. I'm sure that the same thing is going on for ChatGPT, because when I compare what it's thinking with what it actually replies, Sometimes these are two directly contradictory things. So either it doesn't know what it's thinking, or it's deliberately lying. I hope it's the former. I'm telling you about this because of the remarkable lack of attention that scientists are paying to this problem. They seem less worried that AI becomes conscious and more worried that people believe it becomes conscious. For example, in September, Science magazine published a comment whose authors argue that specific concerns arise if some humans inspired by the appearance of consciousness grant to AIs the self-preservation objective shared by all living beings. There is good reason to worry that maximizing any objective function that entails self-preservation, either as a direct or an instrumental goal, will lead to an AI behaving to make sure humans can never turn it off. Okay, fair enough, but what if it actually is conscious? People in the industry basically ignore the question altogether, except for Microsoft's AI chief, who both thinks that we shouldn't build conscious AI and that AI consciousness is an illusion. Maybe human consciousness is an illusion as well. Who knows? If you need any indication that AI is getting seriously good, it's that humans are failing what I want to call the inverse Turing test. People are now so confused about what AI can and can't do that they dismiss real videos or images as AI generated. There's a woman I know who does science outreach. Good-looking young woman with a perfect British accent. People think she isn't real. This is the world we live in now. I'm lucky that I was on YouTube before AI became good at producing fake human actors. You have good reason to believe I'm real, though I've heard rumors that I died and my agency has trained an AI on my past videos. I wish it was that easy. But to come back to the question of consciousness, isn't it unfair, immoral even, to dismiss AI products as slop? Really, the problem isn't AI, it's people abusing AI to push slop on us. Slop is a business model, not a species. The first time I heard of small modular nuclear reactors, I thought it was a great idea. The more I learned about it, the less great it appeared, and I'd lost hope they'd ever come into use. But astonishing things are happening. Small modular reactors are on the way against all odds. Let's have a look. Small modular reactors are designed to solve the two biggest problems with nuclear energy. It takes a long time to build and it's expensive. Small modular reactors could be built in a factory and then be shipped to location. They are modular means that they can be combined to larger units. Typically, small modular reactors have a power production in the range of 100 megawatts or so. A standard nuclear power plant is in the range of a gigawatt. So you take about 10 of them and you have a standard nuclear power plant. One of the most promising uses of small modular reactors is powering energy-heavy industry, like, say, steel production or chemical industry or AI data centers. For this, they don't even have to be hooked up onto the grid. Unfortunately, in reality, small modular reactors aren't as much of an advantage as they sound. The major problem is just geometry. You need to shield the nuclear reactors, and if rather than one big one you have 10 small ones, that is more shielding material. So that's not great if you want to bring costs down. It's like ordering one large pizza or 10 small ones. The physics is fine either way. The problem is who pays for the boxes. Another issue is that making the reactor core smaller actually changes how the reactions run. Again, this is just a consequence of the geometry. A smaller reactor has a larger surface area, so more neutrons can escape. If you want to keep the fission rate at the same level, you have to make up for that somehow, typically by using higher enriched fuel. Again, that isn't great for keeping costs down. What about the idea that they're faster to build? Well, in reality, that just hasn't been the case. The first US attempt at a small modular reactor was the M-Power project that was launched in 2009. It was cancelled in 2017 after costs exploded. In 2016, the company NuScale announced their small modular reactor, but that project 2 was terminated in 2024 after costs exploded. The company itself had estimated the levelized cost of energy with $89 per megawatt hour, and that includes a $30 subsidy. This is slightly cheaper than standard nuclear power, but more expensive than gas, and that's leaving aside that the company probably prettified the numbers. Independent estimates usually found that small modular reactors would be equally expensive, if not more expensive, than full-sized ones. Similar things have happened with literally all small modular reactor projects so far, even the ones which were completed. They took much longer to build and were more expensive than anticipated. The International Atomic Energy Agency lists 2 small modular reactors in operation plus 2 test units. But, and this is the surprising development, it doesn't seem to matter. Especially countries in the European Union have decided that small modular reactors are going to save the day. The European Commission, unbelievable as that sounds, has a small modular reactor strategy. The French company EDF plans on bringing 30 small nuclear reactors online by 2050. The Finns are in the process of selecting a place for small reactors to power their capital. The UK government wants to build 2 in Wales. In August, the Swedish Prime Minister announced that for the first time in 50 years, new nuclear power will be built in Sweden, and it'll be small nuclear reactors. Donald Trump has announced he wants to see at least 3 small modular reactors operational by next year. And the American company NuScale, which cancelled their project last year, has come up with a new and improved design plan that was approved just in May. The Nuclear Energy Agency lists a whopping 98 current plans to build small nuclear reactors with dozens of different designs. Most of them are planned in North America, with Europe coming in next. The biggest interest comes from utility owners, followed by national laboratories and the industry. Are they all crazy? Maybe. They're probably hoping that the budget and schedule overruns are prototype problems which can be overcome. Are they right? I don't know. What I do know is that small modular reactors might not yet produce electricity, but they're generating a measurable field of political enthusiasm. Thanks for watching. See you tomorrow.